In this video, we will be looking at the difference between tolerance and variation. A lot of experienced engineers get tolerance and variation muddled up, with quite an alarming number thinking both words mean the same thing. Spoiler alert, they don't. This video provides an understanding of tolerance and variation, as well as explaining how they are linked. Let's start by taking a closer look at tolerance. We are subject to tolerances all around us. For example, our clothes sizes are made to fit within a specified tolerance. As a customer, we need to determine which size will fit us best by considering the range of size the clothes will fit. In our schooling, work is assessed with grades. Grades are split into boundaries, where we need to get a certain number of marks to achieve each level. Therefore, each grade is effectively a tolerance of either number of marks or sometimes percentage of correct answers. In part geometry terms, the tolerance is simply specifying the acceptable range for the geometry. We can think about it as a theoretical specification. We typically find part tolerances on engineering drawings. Variation is what we see in reality. It is important to recognize that it's impossible to build multiple parts to the exact same geometry. Variation is the term used to describe the spread of measures between the parts. The larger the variation, the larger the spread of measures. At the end of this video, I will share a link to another video talking you through how we can actually calculate variation. So how does tolerance and variation relate? Whilst it is possible to assess variation on its own, this gives limited feedback. In reality, we always have a tolerance the parts need to achieve. It is possible to assess the variation against the tolerance. So let's now summarize by comparing key differences between a tolerance and variation. Tolerance is a design specification, variation is the distribution of data. Whilst a tolerance is a theoretical value, variation is what we see in reality. A tolerance cannot be measured. If we measure multiple physical parts, we can calculate the variation. Finally, we can assess variation against a tolerance. A big thank you for checking this video out. I hope it's been useful to you. If it has, please remember to hit the like button and don't forget to subscribe for more content like this. As mentioned earlier, if you want to find out how we can actually measure variation, please check it out now using the link on the screen.